Hello everybody. This particular presentation seeks to more or less introduce the listener to process simulation, right? Because of the role that process simulation plays in the entire context of the biorefinery, biomass, biofuel scenarios discussed previously. Now, process simulation is used in the design, analysis, development, and indeed optimization of technical processes, right? So in other words, utilize process simulation, chemical processes, environmental systems, complex manufacturing operations, biological processes, etc., right? So in other words, process simulation seeks to open up new possibilities with respect to quality assurance by utilizing simulators to visualize processing data, right? So we can say that process simulation can guide and minimize experimental research. In other words, rather than doing something or undergoing a particular process on a large scale at high cost, we have an opportunity to simulate the process, right, to better understand how the system will react. Now, when dealing with process simulation, we need to understand that process simulation on its own does not negate the need for experimental research, but it actually complements experimental research, right? In other words, if we could undertake the experiment on a small scale, like a bench scale experimental study, we have the opportunity to utilize the data obtained from the experiment as data as inputs, right, in a simulator. Right now, in this case, I have selected the utilization of Aspen Plus as a preferred simulators for beginners in chemical engineering and process engineering studies. Now, what is Aspen Plus? Right, a lot of people are always confused with respect to the technicalities of this particular software, forgetting indeed that it's actually quite straightforward, to be quite honest with you. Now, what process simulation does utilizing Aspen Plus is that it allows the user to build a process model, then simulate it using complex calculations, which integrates equations, regressions, equations, etc., etc. So you have the opportunity to build the models that best illustrate or best explain a particular system, right? So the applicability of such systems or such technologies, such simulators is far-reaching. Now, there's a need for you to have a solid understanding of the underlying chemical engineering principles when employing simulators. It is crucial that the user of such simulation software should understand, at least have an idea of, say, column behavior in terms of using the distillation column. You should know how the column should behave, right? You should also understand reaction kinetics. You should understand basic stoichiometric relations, because you need that basic understanding to be able to even apply or utilize Aspen Plus, right? So what I'm going to be doing throughout the course of this particular course is to present, I believe, a simplified approach to better understanding what Aspen Plus is all about, what process simulation is all about, so that our users the users can be able to apply it in their chemical engineering, plant design projects, and so on. Now, given a process design and an appropriate set of thermodynamic models, right, Aspen Plus is able to utilize these mathematical models to predict the performance of the process. Now, Aspen Plus is similar to existing open source software with the same software. However, the beauty of Aspen Plus is that it enables you to specify chemical components without needing to define the properties, because these properties have already been defined within the simulator, right? Now, Aspen Plus also has a unique ability to be able to, right, handle very complex processes. So you have the ability to handle multi-column separation systems, chemical reactors, indeed electrolyte solutions, such as a chloralkane used in the chloralkali industry, and indeed complex recycle bypass streams and processes. So the advantages of Aspen Plus indeed cannot be overemphasized.